There's a process happening in your skull, but most people have never heard of it. It only switches on when you're asleep. This process involves your brain cells physically shrinking, and for a good reason. So, if you think you're fine running on 5 hours a night, you should probably start looking at sleep more seriously, because skipping it comes with a price. The cleaning crew. In 2012, a neuroscientist named Maken Nedergaard from the University of Rochester discovered something that had been hiding in plain sight for the entire history of human medicine. She found a previously unknown network that clears toxic waste from the brain. This system uses cerebrospinal fluid to flush away proteins such as beta amyloid and tau, substances linked to Alzheimer's and other neurodegenerative diseases. They named it the glymphatic system. And the G is not a typo. It's named after glial cells, the support cells in your brain that make this entire operation possible. The thing is, for most of the 20th century, doctors assumed the brain simply didn't have a dedicated waste clearance network the way the rest of your body does. Your liver, your kidneys, your lymphatic system, all of it had obvious plumbing. The brain supposedly just sat there accumulating whatever it accumulated. It took until 2012 for anyone to prove that assumption wrong, which tells you something humbling about how much of our own biology remains undiscovered. The part that will probably unsettle you is the timing. This cleaning process is most active during deep, non-REM sleep. Picture your brain tissue loosening its grip just slightly every single night, so that a wave of fluid can move through and carry away the cellular debris of the day. It's not very different from a city that only runs its sewage system between 2 a.m. and 6 a.m. If you don't give it that window, you get anything but an empty street. And in this case, it's all happening inside the same organ that's supposed to be keeping you sharp and focused. Even the sleep position appears to influence its efficiency. Research from Stony Brook University suggests that sleeping on your side may optimize the flow of cerebrospinal fluid through the brain's waste clearance channels more effectively than sleeping on your back or stomach. The reason seems to come down to simple geometry. The angle and orientation of the brain relative to gravity affects how readily fluid can move through the interstitial spaces between cells. Interestingly, this may not be a coincidence. Most mammals, including humans, tend to default to side sleeping. Human studies have found that even one night of sleep loss leads to less efficient clearance of amyloid beta and tau from the brain. One missed night of proper sleep, and your brain's ability to clear out the exact proteins associated with dementia measurably drops. Over time, such impairment may allow toxic substances to accumulate, which would explain why long-term sleep problems are associated with cognitive decline and increased risk of neurodegenerative conditions. We're talking about a plausible mechanism connecting habits, such as scrolling, to some of the most feared diseases in modern medicine. But if you think sleeping pills will help, we have some bad news. Nedergaard's team found that the commonly prescribed sleep aid, zolpidem, the active ingredient in Ambien, suppressed glymphatic activity in mice. So, the pill millions of people take to force themselves into sleep may interfere with the very cleaning process that sleep exists to provide. The sedation looks like sleep from the outside. Apparently, it's not doing the same job on the inside. In plain terms, someone can technically be asleep for 8 hours, wake up feeling like they slept, and still be shortchanging the one process that sleep was supposed to bring. This, however, is only part of the equation. The night shift that builds your memory. There's something you should know about studying, working, or trying to remember anything important. The moment you learn something is not the moment it becomes a memory. That happens later, while you're asleep. The prevailing theory of active systems consolidation suggests that during sleep, newly acquired memories, which are initially stored in the hippocampus, are gradually transferred and integrated into cortical networks, where they become more permanent and resistant to interference. In other words, your hippocampus is a temporary holding cell, a whiteboard. Whatever you learn today is sitting there waiting for sleep to move it into long-term cortical storage where it can stick. Your brain is, quite literally, replaying the day's events at high speed while you're unconscious, strengthening the connections that matter and letting the irrelevant ones fade. Researchers studying this in animals have watched it happen almost in real time. A rat that ran a maze that day will show the exact same firing pattern in its hippocampus hours later during sleep, compressed and replayed, like a highlight reel running on fast forward while the animal lies still. So what happens if you interrupt that process? Many studies have consistently demonstrated that sleep deprivation following learning experiences severely disrupts memory consolidation, leading to impaired retention and recall performance. Just how many times have you stayed up late to study? And how many of those times have you actually managed to remember what you read? Not nearly enough, right? Researchers have gone down to the level of individual brain cells to find out exactly how this damage happens. In mice, 5 hours of sleep deprivation decreased dendritic spine numbers selectively in the hippocampal area responsible for memory, along with measurable reductions in dendrite length. Dendritic spines are the tiny physical structures where neurons connect to each other. In plain terms, this is where the memories are built, synapse by synapse. 5 hours of lost sleep, and the brain starts dismantling its own architecture. Underneath that physical change is a molecular chain reaction that scientists have now traced almost completely. Sleep deprivation impairs memory consolidation by inhibiting the synthesis of proteins necessary for synaptic plasticity, thereby reducing neuronal excitability and synaptic strength formation. One missed night sets off a cascade. A signaling pathway gets disrupted, a key enzyme gets overactive, and the physical scaffolding of a memory gets weaker before it ever has the chance to harden into something permanent. It's a little like pulling wet concrete out of its mold before it's cured. The shape was there. It just never got the chance to settle. On the positive note, the damage isn't necessarily permanent after a single bad night. Your brain can rebuild what it lost, but only if you give it the sleep to do so. One study has shown that as little as 3 hours of recovery, sleep can be enough to restore the relevant signaling and structural connectivity. So try and remember, if you don't get your sleep dose, you are actively degrading the exact cognitive machinery you're trying to use. And don't be fooled, you can feel mentally present, even confident, while the very system responsible for retaining what you're working on is operating at a measurable deficit. Let me explain. When focus and creativity disappear, concentration doesn't vanish all at once when you're sleep deprived. And that's the very thing that makes it so dangerous. It erodes in a way that's almost invisible to the person experiencing it, which means you can be operating at a fraction of your real capacity and still feel basically okay. Neuroscience explains that the prefrontal cortex is the part of your brain responsible for executive function. Executive functions, such as working memory, impulse control, and decision-making, are notably impaired due to the prefrontal cortex's heightened sensitivity to insufficient sleep. To make matters worse, your brain tries to hide this from you. Initially, it tries to compensate for executive dysfunction by increasing prefrontal cortex activation. However, these compensatory mechanisms become less and less effective with sustained sleep deprivation. Your brain throws more effort at the problem to keep performance looking normal. For a while, it works. You feel tired, but functional. Then the compensation runs out, and the gap between how sharp you think you are and how sharp you actually are widens. Quite a lot. It's the cognitive equivalent of a company covering a budget shortfall with a credit card. This shows up in concrete, measurable failures. Researchers observed that individuals undergoing total sleep deprivation exhibited impaired feedback-based decision-making. They suggest that despite an initial effort to maintain cognitive performance, executive processes, strategic thinking, or adaptive control, for example, these begin to deteriorate. Adaptive control, strategic thinking, the exact mental tools you need for your day-to-day life are running on a system that's degrading while telling you it's fine. There's also an emotional side to this, and almost nobody connects it back to sleep. Neuroimaging studies show that sleep deprivation causes the amygdala, which is the brain's center for processing emotions, to become up to 60% more reactive to negative stimuli. 60%. At the same time, the prefrontal cortex, which manages reasoning and self-control, becomes less active. This imbalance makes emotional responses stronger, faster, and harder to regulate. So, no, You're not imagining that small frustrations feel bigger when you're exhausted. There's a measurable neurological reason your patience runs out faster on no sleep, and it has nothing to do with willpower. We are not done though. Sleep deprivation has also been found to amplify reactivity in the brain's reward networks, biasing how positive experiences get appraised. A sleep-deprived brain can overreact to rewards, which would help explain why exhaustion is so often paired with impulsive spending, late-night snacking, or all those risky decisions that felt thrilling in the moment and baffling the very next morning. And what about creativity? The thing we tend to associate with inspiration striking at 2 a.m., not with rest? The research actually points the other way. Sleep reorganizes and integrates memories in a way that promotes insight and creativity. Turns out that the aha moment depends on the same offline consolidation process that sleep deprivation interrupts. The exhausted, wired-feeling creativity of an all-nighter is not the same thing as the genuine cognitive flexibility a rested brain can produce. One feels productive, the other actually is. Plenty of history's celebrated late-night genius stories survive because we remember the breakthrough and conveniently forget the years of well-rested groundwork that made it possible. The myth is seductive. Neuroscience, however, doesn't agree. Of course, none of this resets itself just because you finally feel awake. That's the detail that turns this from a personal inconvenience into something closer to a public health emergency. The cost that keeps getting higher. When sleep is persistently reduced or fragmented, memory is particularly affected, with impairments in encoding, consolidation, and retrieval of information about both self and the environment. All three stages of memory. What's more, a 2015 study published in Sleep Medicine Reviews found that individuals who slept less than 6 hours per night were far more likely to develop symptoms of depression and anxiety. We're talking about a meaningful, measurable jump in mental health risk, tied directly to a number, 6 hours, that millions of people treat as a perfectly normal night. As you might imagine, it only gets worse with time. Your brain's capacity to grow new neurons in the exact region responsible for memory and learning slows down the longer the sleep debt continues. Memory impairments caused by sleep deprivation were still present, though less severe, even after a night of recovery sleep, with recovery sleep reducing the damage by roughly half, rather than eliminating it. That means the common assumption, "I'll just catch up this weekend," isn't how this actually works. The damage from a string of short nights leaves a residue, and if the short nights keep coming faster than the recovery can catch up, that residue becomes the new baseline. Maybe the most viscerally concrete way to understand the cumulative cost is to compare it to something we already legislate against. The crash risk associated with driving after only 4 to 5 hours of sleep is comparable to the crash risk associated with a blood alcohol concentration of roughly 0.12 to 0.15. That's already well above the legal limit in most countries, and it's the risk profile of someone who simply had a short night without taking a single sip. After 17 to 19 hours of wakefulness, performance impairment matches a blood alcohol concentration of 0.05%, and after 24 hours without sleep, it reaches the equivalent of 0.10%. So, a person who pulled an all-nighter and then gets behind the wheel is, by the numbers, no different from a legally drunk driver, except nobody administers a test, and they themselves usually have no idea. Drivers' ability to judge their own level of sleep-related impairment appears to be limited, and coffee does not reverse it, at least not enough to make a difference. While the caffeine makes you feel more alert, it does very little to restore the actual reaction time and judgment that sleep deprivation has already stolen. An estimated 6,400 people die annually in crashes linked to drowsy driving in the United States alone, a number that almost never makes headlines the way drunk driving fatalities do, despite the underlying impairment being functionally similar. And the damage isn't even confined to the brain. The same sleep loss that degrades memory and judgment is, at the same time, secretly rewriting your immune system. Researchers have found that even one day of sleep deprivation can alter immune function and increase inflammation. And if these shifts persist, they could contribute to long-term inflammatory states and a heightened risk of disease. One day, the same dose that costs you a measurable slice of memory consolidation is simultaneously nudging your immune cells toward an unstable state. Push that single bad night into a sustained pattern, and the numbers get harder to dismiss. Just 5 nights of sleep restriction can lead to the increased production of inflammatory markers, which can, by the way, still be elevated even after 2 full nights of recovery sleep. Add in a higher heart rate and elevated CRP, both established risk factors for cardiovascular disease, and you can call it a disaster. 5 nights to trigger it. On top of everything, researchers at Mount Sinai have found that consistently losing as little as an hour and a half of sleep a night can restructure the immune system's stem cells at the level of their DNA, increasing the risk of inflammatory disorders and heart disease over time. This is also tangled up with breathing, which most people never think to connect to brain health at all. Obstructive sleep apnea has traditionally been linked to hypertension and cognitive dysfunction, but recent epidemiological studies have also linked it to an increased risk for both dementia and its prodromal state, called mild cognitive impairment. There is emerging evidence to suggest that sleep apnea might chronically impair glymphatic clearance, facilitating the formation of the plaques that characterize Alzheimer's disease. Now, if this turns out to be correct, it would mean that millions of people have undiagnosed sleep apnea, meaning they believe they're sleeping 8 hours, while their brain is functionally getting a fraction of the deep, restorative sleep it needs. They feel exhausted, and they have absolutely no idea why. What makes all of this particularly interesting, especially for neuroscientists, is the pattern. Every system we have talked about today depends on the same nightly window, and every one of them is damaged over and over again by the same habit. Deciding, just for tonight, that sleep is the thing you can afford to cut, the last negotiable thing to do. In the end, what should stay with you is the structure underneath all of them. Your brain is running one of the most sophisticated maintenance operations in the known universe, cleaning itself, archiving your memories, rebuilding the very connections that make you who you are. That should fill you with something close to awe. We carry this system around every single day, and yet we almost never think about it. That same fact is exactly why, as we have already said at the beginning, carelessness is so costly. And yet, remarkably, the solution here isn't complicated. And no, it isn't a supplement, a device, or a biohack. Matthew Walker, neuroscientist and author of Why We Sleep, has spent years making a case that most people could meaningfully transform their cognitive health with one change, treating sleep as a non-negotiable appointment rather than a suggestion. The most important thing here is consistency. Going to bed and waking at roughly the same time, even on weekends, does more for your brain's maintenance cycles than almost anything else you might try. It might actually be considered the least negotiable thing you do all day, because somewhere in your skull, every single night, there's a system waiting for the lights to go out, so it can finally start the work of keeping you whole. What did you find most disturbing about the effects of too little sleep? Let us know in the comments, and subscribe to our channel for more.